That was just a test. What is going on, everyone? So today I'm going to be doing a tutorial in Altium on how to make these 4 components right here. So we have 4 surface mount polarized capacitors. And so the reason I chose these 4 footprint sizes, right here we have a 4.3 millimeter by 4.3 millimeter, 5.3 millimeter by 5.3 millimeter, 8.3 millimeter by 8.3 millimeter, and 10.3 millimeter by 10.3 millimeter. So the reason I chose these 4 footprint sizes to do is because these are among the most common footprint sizes you'll see on a manufacturer's website. So say, for example, you're trying to source a capacitor on DigiKey's website. You're most likely to find a capacitor that is one of these 4 footprint sizes, right? I mean, you can go a little bit bigger, but these 4 give you a huge selection. And so it just helps simplify your library. You only have a handful of footprints. So what we'll be going over is, of course, how to make the actual footprint in Altium. So how I made this thing right here, how I added the 3D model. Then we're also going to go into the schematic library, and then I'll show you how I just created the symbol and then what parameters I added to it as well. It's just going to be a complete guide on how to create an Altium component as well. So with that out of the way, before we go any further though, please go ahead and drop a like on the video for me. It helps my channel out immensely, and subscribe if you'd like to stay up to date with any future videos. So with that out of the way, let's just jump right into it. So the first step that we kind of want to do is go to a manufacturer's website and find an example of a component we're trying to make. So I went ahead and did that. I went on DigiKey's website. I just found an example component. So this is like a 10S VPR aluminum. So this is a 4.7 microfarad 10 volt surface mount capacitor. None of this stuff really matters. What really matters is the surface mount land size. That's how you get the footprint size, right? And so I just wanted an example. I started out with 4.3 millimeters by 4.3 millimeters. And then what I did was I just opened up the little data sheet right here, which is this right here. It opens up to this. This is Panasonic's data sheet. And one thing a lot of these manufacturers do is to simplify their data sheets is they actually have a whole bunch of components on one actual data sheet. So for example, if you see down here, they have different size codes, and then it tells you the actual size of the capacitor. So you'll see, hopefully something looks familiar, 4.3 by 4.3, A by B. So we have B by A. So 4.3 by 4.3, 5.3 by 5.3. Here's our 8.3 by 8.3. And then here's our 10.3 by 10.3. So what this data sheet will basically do is it'll tell us how to make all 4 of those capacitors that we want to make. So then we just have to find, so this gives us a size code for the actual capacitor. And then we're going to scroll down here. And then this is going to tell you the actual land space and give you the dimension. So it tells us the space between pads and how big each pad is. And in a nutshell, that's pretty much all the information you really need in order to make a capacitor. So the first one on our list is the 4.3 by 4.3 millimeter capacitor. So that's this one right here. And if we look at the size code, it says B. So we're going to take this information, size code B, scroll down here, and then here it has a table of board size versus capacitor size, board land size, sorry. And so if you see here, size code B, it tells you the dimensions right here. So you have the A and the B and the C. So real quick, let's go into Altium and we'll create a brand new component just so I can show you how I went about doing all these from scratch. And we'll just go and we'll say edit and we'll do example. Underscore. No, we can't do, oh, one pro tip. Do not put underscores in your, well, actually I did put an underscore here. Pro tip. There are some characters that the Altium component footprint library does not like. One of them is this one. And I learned this the hard way. It makes no sense to me why, but do not put this in your footprint because it just like won't recognize it if you do that. So stick to underscores and dashes and stuff like that. So we'll just go underscore cap. Okay. So now we have our example component right here. we're going to go in and let's do place, and we're going to click pad right here. Okay. So here it's going to default to a circular pad. Do not worry. We will change this. And also if you look at the default, go up here into the properties, it says layers multi-layer. We do not want multi-layer because this is a surface mount component. So we're just going to scroll up to top layer, and we're going to put it on top layer. So now we have a pad that is only on the top layer. And then we want to change this from round to rectangular, right? So now we have a pad that's a square. Now it's a surface mount square right here. And then if you look at this, this little purple box right here, this is referred to as the solder mask layer. And so you can set this per your design rules in Altium, but basically what this purple square is set to do is just have, it's going to form like a border around our red square, which is our actual copper pad. And so the rule states that it needs to just grow a certain amount. It needs to form a certain size perimeter around our pad. And so the rule is referred to as solder mask expansion. And so right here we have a tab selector, we have a rule where it does it automatically for us, but we can click manual and then we can actually input the values right here. And then if you click this button, this links and unlinks the top and bottom, so you can make the top and bottom ones different if you wanted to. However, this is a surface mount component, so we only have the top to select because there's no bottom pad. We're going to select back to rule, keep it on the rule setting, that's fine. And then the paste mask expansion right here is this gray square which overlaps the red square perfectly, or so the paste mask goes over the red square. And so if you don't know what the paste mask is for, so whenever during the manufacturing process for PCBs, they have a little stainless steel stencil that they print out, and it makes for applying solder to the copper pads. It simplifies it. So this paste mask helps form the 3D CAD model for the stencil that they use. So it should just match up to our red square perfectly. Okay, so back to this view, right? So what we want to do, click, this is also has a designator of 15. We do not want to do that. We're going to change that to 1. So well, there's only 2 pads on this component, right? So there's pad 1 and pad 2. And we'll talk about linking up the pads to the actual pins on the schematic in a minute. But for now, just select 1. So the next thing we want to do is select the size, right? So if we go back to our data sheet, we know that for size code B, that our capacitor is B by C. So B tall by C wide. So, and this unit is in millimeters. So we're going to go 2.5 millimeters by 1.6 millimeters. Okay. So what we can do is we can also add like a little bit of wiggle room. So maybe we can go, let's just go like 3 millimeters for the height, or the how tall, the height of our pad, right? So if we click right here, this is going to be the height of it. So we're going to call this 3 millimeters. That's the X. So if we click on the Y section, which is going to be the height, and we click 3, this is 3 millimeters is what our units are in. And if your units are in mils right now, you can just hit the hotkey Q, and that changes it to mils, right? So that's how you toggle between mils and millimeters. This data sheet is in millimeters, so we're going to go with the millimeters units, of course. So now that we have the pad set to 3 millimeters tall, and just double check that this is correct. So the B is 3 millimeters tall, and then the C is 1.6, and we're going to round that to 2 millimeters wide. It's okay to have your pad a little bit wider than the actual component. If you see even here that they are telling us, they're instructing us to make it just a tad bit wider than the actual pins on the capacitor. And like I said, even having a little more wiggle room is okay, because the point of these footprints that we're making is that you can interchange many different components on them, right? Like you can put like Panasonic is not the only manufacturer for these types of components, right? So there's a ton of different other companies. Like if we look down here, there's like Nissan, Panasonic, United, whatever, how you say this, Vishay. Worth Electronic, right? So a bunch of different companies make their own capacitors, right? And so we want to create a footprint that can kind of fit all of these. And so they could have some slight variation. I'm not saying it's like we got to make a huge component pad that is like, we got to fit like 6 millimeters by like 8 millimeters to fit all of them. No, it's just a slight amount of variation here. Okay. So that's why I'm adding like 0.5 millimeter here, 0.5 millimeter there. It's okay. It won't hurt anything. Okay, so just real quick, let's go back to the data sheet and double check, right? So 1.6 is the width that we're going for now, 1.6 millimeters is the width. But then we just go down here and it's already 1.52. So just round that to 2, like I said. So boom, this is one pad right here. Okay, so now let's go in and do it again. We just kind of rinse and repeat. You could actually even click, I think you can copy paste, like I said, there you go, copy paste, and we just so I did Control C, Control V, and then we're going to change this designator to 2. So now we have one of 2 pads, right? So next thing we want to do is we need to space these apart appropriately. So if you look, it tells us the how far apart they are. So what we do is we're trying to go, Altium likes to go from center of pad to center of pad, and if you look in our editor, we have the origin is set to the center of this pad. So we're going to use the center of this pad, and we're going to try to figure out where the center of that pad is, because also when you grab it, that's where it grabs the pad. Okay. So looking at this chart, we have that we have a distance of A from edge to edge. And so from middle to middle, we're going to go A into the middle of this one is 1/2 B right here, and then another 1/2 B. So the total distance from center of pad to center of pad is B plus A. So we have B plus A, which is 3.5 millimeters. And this one, we want to put it right on the money because any wiggle room doesn't really matter or make sense because this is a location and not a size. Okay, so we're going to go with 3.5 millimeters. Take this. So if we look at this, tells us the location, right? So 0 millimeters in the X direction, right? Because it's perfectly lined up with the origin. And if I moved it over here, you see how it changes, right? So we're going to go 0 millimeters right here. So 0. And then we're going to go 3.5. Okay, so that's where our capacitor is located. So this is basically the bare minimum you need in order to complete the footprint. Let's go back and double check that we have 3.5 and 3.5. Now let's go to my example real quick. Okay, so the next thing we want to do is we want to add a 3D model to this, I think is the next step. So first thing we want to do is hit edit and go set reference, and we're going to go center. So that's going to put us right in the middle of both of these components because that's where the basis for our 3D model is going to go, is you place it based on the center, right? And so a little tip for getting 3D models is that if you actually go to there, so this is again the little homepage for the component that we're making. Scroll down to the bottom and you'll see it says EDA/CAD models. And so you have 2 different options, 2 different like companies or providers make these models. And so I just clicked the one from Snap EDA. So I click this tab up here and boom. So this is the default screen. So you can actually generate full on footprints and schematic symbols. However, you don't really need to do this every time. Like we're only making 1 footprint. So it's okay just to make it this way. And it's also really important to know how to make your own footprints in case you need to modify them ever, right? So we're just going to click download a 3D model. So when you click on this Snap EDA link, it'll take you to here. And then what you want to do is just click download 3D model. And so what it's going to do is it's going to literally send you a little step file. This is literally a step file. Direct download. Okay, so once you have the step file downloaded, you're going to go with place and you're going to do 3D body. And then it's going to open up a little folder for you, and then you just go find the step file wherever you download it to. I put mine on my desktop and we're going to click open. Okay, so then you're going to get this little image here. If you look down at the bottom, you see we're on the mechanical layer, right? So you're just going to scroll right over and hover right over the center origin and place. So one important step we need to follow before we go any further is there's like a default orientation for these components, and sometimes it doesn't always line up with how you laid out your pad. So real quick, you want to go to the view 3D layout mode and make sure you see, okay, so this doesn't make any sense because it's the wrong way. It needs to be rotated like 90 degrees in the, I'm not sure which, we're just going to do trial and error to figure out. I do not know these. Oh, wait, we can figure out based on this axis, right? It's based on the Z axis, I think. Let's change this to 90 and then boom. Okay, so you see looking at this is turned the wrong way. Like it needs to be rotated 90 degrees in the Z axis, right? So when you're looking from the top down, it needs to be rotated clockwise or counterclockwise 90 degrees. So what we're going to do is hit rotation Z 90. And it's going to turn like that, and boom, there you go. Look at that. It's right on the pads for us now, and it fits perfectly, right? So that's pretty much all you need to do to get the 3D model on there. So now we can proceed with the next steps. So the last thing you want to do is add some overlay or some solder mask, or not solder mask, some silk screen to your component, just so from a validation perspective, whenever you get this PCB manufactured, it makes it easy to work with, right? So we're just gonna put some indicators denoting which pin is the polarized pin, and also just some something to highlight just the component itself, just to give a brief outline, just to help your eyes track it and stuff like that. So I've already selected top overlay, and then what we're gonna do is pin 1 is the polarized pin. Okay, so the next thing we want to do is add some markings on the silk screen to just help identify certain parts. Okay, so the next thing we want to do is add some markings on the silk screen in order just to help us work with the component whenever it gets manufactured in real life. So one thing we want to add is a little marking to denote which pin is the polarized pin. And then the other thing we want to note is just like a little outline of our component, just to help your eyes track and follow it, okay? Okay, so the first thing we want to do is we're going to add a little dot in order to denote the side of the capacitor that is polarized. Now, one thing I'll say, it's important to know that this is just a completely arbitrary at this point. The only thing that matters is that they match, meaning that your schematic symbol matches your component footprint. So if on the capacitor you draw pin 1 to be the polarized one, and on here you have pin 2 as a polarized one, your capacitor is going to be mounted backwards when they manufacture it, and that's a big no-no. Like it'll not work, right? So we're going to make a little note here but we also have to make sure that it carries over to when we do our schematic. So we're going to pick pin 1 as the polarized one. We're going to do place, and then we're going to do arc, or full circle, I should say. So if you make it small enough and your arc thick enough, if you make the width thick enough and then you make the circle small enough, it turns it to be just a dot. So we're going to go right about here and then see how, yeah, just like that. And then boom, it's a dot. Okay, just like that. Now we have our dot, and let's move it down just a little bit. Okay, so the next thing we do is just kind of outline. Next thing we do is just kind of. So the next thing we want to do is just outline the component body, just so it's easier for your eyes to track and follow whenever it gets manufactured on the PCB. We're gonna click place, line, and then we're just gonna kind of trace the outline of this. And this is okay if it touches it, because this is going to be like underneath the component, so it won't actually interfere when we manufacture it for the component body. But whenever we we do not want the silk screen to touch our actual pad or our solder mask as well. So we need to keep a clearance between there and there. So that looks good for that. And then there you go. So this is pretty much all you need. At this point, the footprint's completely done. So what we can do is go on to the schematic symbol portion of this tutorial. And so let's just do that. So let's go over here. So let's start out by creating an example component. So we'll click on the add button, then we'll go component, and we're going to change this to example _ cap. Okay. So one trick I like to do is if I've already created a component, a schematic symbol before in my library, like I have for this one, I'm just going to go over there. You can actually do, you can actually just find the component. So here it is right here, and look at, boom, you can actually just Control C, Control V, and boom, it's placed right there for you. Okay, so if you've created this component before, then just Control C, Control V. However, I want to show you how to create it from scratch, because you might not have, this might be your first component you're ever making, right? So what we're going to do is we're going to click up here, we're going to go place, and then we're going to do pin. We're going to place it right here, and then we're going to do another one. So important notes on the pins is that this end right here is the hot end, you'll call it. So this is the end that needs to be connected to the wires, right? That this does not need to be fed into the internal parts of your capacitor. So the next thing we want to do is change our designators and our name to 1 and 1, and we'll hide the name of the pin, but we don't necessarily want to hide the designator. You can if you want. This is just personal preference, kind of how you want your schematic to look, but just make sure the name and designators should match, and then you can hide or show depending on your taste, right? Another thing I like to do is this pen length at 300 mils, 300 mils is just a little bit too long. I think something like 150 or even 100 might be more appropriate. Let's just go with 150. Do 150 again. Okay, so now we have 150 mil pins, right? And remember I said that that pin 1 is going to be the polarized pin. So let's go back to this example we have here. This is what I mean by the polarized one, is the one with the plus on the side of it, right? So we need to keep that in mind. So this is pin 1. And so what we're going to do is we're going to go with place. So now we need to draw the little... So next up, we're going to draw the actual lines that kind of make up the iconic capacitor symbol, which is just the plates, right? So we'll go with place, line. We'll just take that and draw it across right there. Okay, so this showed up as black and we want it to be a beautiful baby blue. So we're going to go up here to the top right, click this line and select this color right here. And that's how you get your beautiful baby blue. So the next one is going to be a little bit tricky because it's actually an arc and not a straight line. So what we're going to do is we're going to go with place and we're going to do elliptical arc, right? And so we kind of have to start this the same way we did our other one. So what we're going to do is we're going to go and hit place and we're going to do elliptical arc. So we'll click once. This is how you determine the width of it. Click again. So what we are going to do is we're going to go and select arc. So what we're going to do is just click a starting point, click a radius. So what we're going to do, is we're going to just go and click place, arc, and then we're going to click a starting location, which is just right here. Then we're going to grow it till it's about the same diameter as the first plate. So we're going to hit click, and then we're going to shrink it down until about here, I think is good. And then we'll do the same thing here. So this is kind of our, and we're going to kind of just fiddle with it a little bit until we kind of get it the way we want it. So I kind of want the ellipses a little bit, the bend in the arc is not as harsh in the original one I showed. And so what we're going to do is we're going to flatten the plates out. And then what we'll do is we'll change the radius to like 150, right? So you see how it made it a bit longer, but it's also the curvature is a little bit less, right? And so what we can even do is we can change this, say we want it even less harsh. We go like 200, right? But then we shrink it down to here and then we can also just move it over like that, right? So now we get a much softer curve. When we make sure it's the same length like that. So then lastly, we can just kind of go and we'll hit, we'll change our grid down here. I changed the grid to 10 so we can zoom in real close. We'll kind of put them certain distance apart. And while we're in this close, we can also shrink this. And then there you go. So now it looks like a real life capacitor. In fact, let's just shrink this in just a hair more. Okay, so now this looks like like an actual capacitor that you would see on a schematic. And then lastly, I want to hide these components. And then I want to denote which end is the polarized end. I'm going to hit place, line, and then make a little plus here in the corner. Okay. So we'll highlight this and let's bring it in a little bit. And then we're going to do change the color of this as well to baby blue. And then there you go. Now you have a complete capacitor. So the next thing we want to do is we want to link the footprint that we just created with the schematic symbol that we just created. So one thing I want to show you before you try to do this is, actually I'll show you right now, is if I go and click footprint, right, remember the name of our footprint was example_cap. If we scroll down, we're not going to see it, right? There's no example cap footprint. And the reason for that is because we actually have not saved our PCB library. So if you create a library footprint and you're trying to link it to your schematic symbol, you need to make sure that you have saved and updated your library. So we'll hit save on both of these. Oops, we'll hit save here. And then now we'll try, go back to our schematic library. So now we'll try footprint and example cap. And then there you go. And we'll hit remove this one. Okay, and then it shows up perfectly. So the next thing we want to do is we want to add parameters to this schematic, right? So what we'll do is you go over here and you click add, and then you'll hit parameter. And then what you do is you'll name a parameter. For example, we're going to name manufacturer. And then what we'll do is we'll go back to our component and we'll say, it's going to show up here, it says manufacturer is Panasonic electronic components. And so what we do is like copy, and then we'll hit Control V, and then it pastes it in there. And then we're going to repeat this process for some other parameters. So the other one is going to be manufacturer part number. Right, these are two of the most important parameters that you need for a component, because it helps you make up your BOM with this information. So the manufacturer part number is right here. We're just going to copy, and we're going to hit paste, and then there you go. So we're just going to repeat this process, and I'll go down and let me just quickly show you one of my example components that I've already made. And so here we have, like I said, the symbol. Here's the linked footprint, and then what we're going to do is here are all of the parameters that I have chosen that I think are important just for either BOM creation or just use in a schematic. So we have type is capacitor, type is aluminum electrolytic, value is 4.7 microfarads, the voltage rating of the capacitor is 50 volts, the manufacturer part number, and then the package size. So this is the complete list of components, or of component parameters that I think are important. Another thing that I think matters is make sure in the comment section, I usually put the value of the component. So this one is 4.7 microfarads, and then a brief description, which just lists some of the fast facts, like the tolerance, the material it's made out of, the capacitor rating, the voltage rating, what type of mounting technology you're using, because there's like through hole, there's like a chip capacitors, and this one's like a surface mount radial can. So that pretty much covers like everything that you need for a single component, right? So going back here and say we're going to do the other one. So we wanted to do we just did the 4.3 by 4.3 millimeter. So let's say we want to do the 5.3 by 5.3, and I'm going to use this same example as a placeholder, right? So we're just going to get rid of all of this and say we're trying to do the 5.3 by 5.3. So what we would do was we would go down into our data sheet and just do the same exact process that we did for the 4.3. Right? So we would find the case code size, and we know that, sorry, we got to scroll up. We would find the case code size right here. It says 5.3 case code is C, right? So then we scroll down here to this little table, we find C, we find our A, B, and C values, right? And we create it again. So we know that this time A is 1.5, B is 2.8, C is 1.6. And then we would just rinse and repeat the same exact process. So it would be the exact same for the 4.3 millimeter process. The only difference would be whenever I go back to this page is the 3D model for the 5.3 millimeter capacitor would not work with the 5.3. So the only difference with the 5.3 millimeter capacitor is if we go to the manufacturer page right here, if we clicked and downloaded this 3D model, this would not work with this 3D model is made for a 4.3 millimeter capacitor. So what we would do is we would just go back to like a little search, right? And we would say, we would get rid of the surface mount land size right here. And so what I would do is I would select 5.3 by 5.3. Okay. And then I would find something that had a 3D model linked. So again, this looks like Snap EDA does offer 3D model, and then you would hit 3D model again, and then you would just hit download, just the same exact process that you did for the other one. And then you'd be able to place that 3D model, right? And then the whole process is the exact same, where you draw your pads, you make your little overlay, you add your 3D model, and then you do the same exact thing in the schematic portion, right? In this time, now that you already made one, you can just do a quick Control-C, Control-V. Another little pro tip is you can actually just completely copy an entire component, and that is very handy. So you hit right click and you go copy, and then I can hit paste, right? And just copies and paste it. And so what I would do is then I would edit, and then I would change the design item ID to something more meaningful. Like I would just keep iterating the number. So I might go like 32, right? That's the next up in line. And so this one has the added benefit. So copying the entire component in the library has added benefits over just copying the symbol, and that you also copy all of the parameters as well, right? So you don't have to retype in type, subtype value, voltage, etc. You have to make sure you change these appropriately if it's a different value, if it's a different manufacturer, etc. So that's the only thing to note there, but it helps speed up the process, right? Because you're going to be making tons and tons of components whenever you start designing your own boards. So it's really helpful to know how to efficiently do this, right? So we're going to get rid of this, and then we'll get rid of the example as well, because we don't need this because I've already created a bunch. So that pretty much covers everything I wanted to show you in this video. Hopefully this helped you out a lot. If you have any questions about component creation, drop a comment down below, and then I can show you how to make even more stuff as well. I'll be making some more videos on this. So yeah, so thank you so much if you made it to the end of this video, and hopefully I will see you in the next one.